Lesson 30, angles and angle measure. Okay, so good news is for this lesson, it's actually going to be quite a lot of review from Math 20-1. A couple new things, but for the most part, it's going to be stuff you guys know already. So a couple of things about measuring angles here. So when we're measuring angles, if you remember, we always measure from what's called the initial arm. Okay, and the initial arm is really just from the positive part of the x-axis, right? So that's going to be where we're measuring from. And then where we're measuring to is called the terminal arm, right? So then this would be the angle that we make. Where those two different arms meet is called the vertex, okay? And also remember our quadrants, right? So this is the quadrant 1 starts here, and then it counts from, it starts counting counterclockwise, right? So quadrant 1, quadrant 2, 3, and 4. All right. Oh, so yeah, that's what I was just saying there. So another part of this, if we measure things counterclockwise, that's going to be considered a positive angle. So if I start here, go all the way around, that'd be 360 degrees, and then keep going around, that would be a 500 degree angle. But if I did the exact same thing in reverse, it would be a negative 500 degree angle. So if we were going to sketch, some of these things, right? Then we'd make a little Cartesian plane. Good enough. And then starting from the positive x, we would go around, and we want to remember some of our markers, right? So this is 0 degrees, this is 90 degrees, this is 180, and this is 270. Okay, so if I'm going around, I know I'm past 90, I'm definitely past 180, and I'm past 270, right? So I'm going to be down over here somewhere. Okay, so there, good enough. That's good enough for our sketch right now. So we'd say that that angle was 315 degrees, and we end up in quadrant 4. All right, doing the next one here. So in this one, just careful because it's a negative, right? So now we're going the other way. So we can imagine now that this would be like 90 degrees, 180, and 270. Everything's kind of backwards, right? So if we're starting here, now we're going around, we're past 90, we're past 180, we're not quite to 270, so we're somewhere in there. So there you go. That would be our negative 230 angle. So we end up in quadrant 2 now. Oh, I should probably keep it consistent. Quadrant 2 or quadrant 4. We like to be fancy and do Roman numerals in math. Okay. All right, so I think you guys get the idea. I'll skip through this 635 one, but give it a try if you want on that one too. So, all right, coterminal angles. So this is an important concept. This word comes up a lot in your guys' questions, so make sure you're really paying attention on this one. So anytime the anytime the terminal arm is in the same position, no matter how many positive or negative rotations there are, a coterminal angle is formed. Okay, so what that means is if I, let's say, look at 45 here, right? So let's say that's my, like where I'm starting. Then can you guys see that it would be the exact same place I end up if I go negative 315 around here? So the terminal arm ends on the same place. So we call those things coterminal, like they're both terminal, right? At the same place. And then you can see with 405, same thing, it ends at the same spot there, right? So those are all coterminal angles. Okay, so the general form for coterminal angles can be written in the following forms. Okay, so this will be important. You guys will see this quite a lot as we go forward. So the coterminal angle, right, is equal to, and this is the principal angle. So now the principal angle, what do I mean by that? The principal angle is going to be just the angle. Well, in this case, it was 45 degrees. It's like your initial angle, and it's always going to be the angle between 0 and 360 degrees. Okay, or 0 and 2 pi, which I'll get into in a second. But that's going to be like our principal. It's like our beginning, right? And then we're going to add 360 degrees times n, where n is an integer. So it's worth just kind of talking about this a little bit more. If we started at 45 degrees, right, and then we added, just let's say n was equal to 1, well then we're just adding 360 degrees. Well, that makes sense. Then that would mean that I go all the way around and then I'm back here again, right? So that would be 1. But what if I put in 2? Well, now that's just starting from here, going all the way around, and then going all the way around again, right? And again, you're back there again, okay? But you might notice, well, what about going the other way, right? What about like the subtracting? So yeah, it should be the case that if I start at 45 degrees and then subtract 360 degrees, well, that would be the same thing. Again, you're back where you started. Now, this actually is taking care of the subtraction part. And the reason that it is because if we look at this last part, it says, so this is 360 times n, where n is a member of the integers. So remember what the integers are, right? The integers are negative numbers and positive numbers. So if we're including the integers, that means that what if I put -1 in for n? Okay, well then that will be plus -360, which is really the same thing as subtracting 360. Okay, so it can be written this way with n as a member of the integers, or it can be written this way, which is the same idea. Now instead of just plus, we're saying plus or minus 360 times n, where n is now just a natural number, so just the positive numbers now, right? But the negative is being taken care of with this plus or minus 360. Okay, so just want to show you both because both of those situations will show up in questions and you need to know what they mean. Now below, this is exactly the same thing, but if we're measuring things in radians, then instead of 360 degrees, we're going to be adding or subtracting 2 pi radians. And we'll talk again in a minute about what we mean by radians. So, all right, so I got a little ahead of myself with the principal angle thing. Like I was saying in the question above, the principal angle it would be that 45 degrees, right? So that's always going to be between 0 and 360 or 0 and 2 pi, right? Okay, so for each example, or for each of the following degrees, determine the coterminal angles with the following domain. So they give us a domain here of, so the angle has to be greater than or equal to -360 degrees or less than or equal to 360 degrees. But then when we're done that, they want us to write the general solution. So general solution looks like this, right? For all coterminal angles. So that's without the domain anymore. Okay, so let's do it for this domain first. So I'll say 45 degrees. So what we want to do is we want to go, okay, 145. And then really I want to either add or subtract 360 degrees, right? So if I'm starting at 145, and let's just add it first, right? So if I go 145 plus 360, we end up getting 505 degrees. Okay, well, that's not part of our domain, right? That's outside, that's above 360, so that doesn't count, that's not within it. But if I go 145 minus 360, then I'm -215 degrees, and that is, right? That is within our domain here, right? All right, so that would be the one solution if we were restricted by this domain, okay? But now if we want to give a general solution, that means that there would actually be like an infinite number of solutions, right? You could keep going around the circle an infinite number of times, right? So the solution or the formula for that would be 145. So 145 degrees, and then plus 360 n, and 360 degrees n, we should say, where n is a member of the integers. Okay, so just one thing to know this here too, right? I chose 145, and that will be right? Because we want to have the smallest positive angle, right? So here, let's write that down. And this one is the smallest positive angle, right? But it might not have been. They might have given us a number, well, kind of like this one, where that's not the smallest positive angle. So I kind of gave that one away probably for the next one here. But all right, so let's do B. So we want to go 730. And then really we just want to start adding 360 or subtracting 360 and just make sure that it just falls within that range. Okay, so 730, I'm just going to write plus or minus 360. and then just give you all the different answers it could be there with both of them. So if you added, you would end up getting 1090 degrees, right? But that's outside of our domain. Okay, so that one can't work. If we subtracted 360, we get 370. Okay, so 370, that's not in our domain either, right? So, okay, is there nothing in our domain? Well, not really, right? We could subtract 360 again. So if we go 370 minus 360, then we are back within our domain. Now we're at negative, now we're at 10 degrees. Okay, so 10 degrees is within our domain. And then let's do it again and see if we're still in there. So then 10 degrees minus 360. And then we will be at negative 350 degrees. So both of those were, right? So our two angles in the end here were 10 degrees and negative 350 degrees. Okay? But now if we're going to make a general solution for this, so now that means we're not caring about the domain here, then that would be, well, smallest positive angle. So I'm going to use 10. Okay, so it's going to be 10 degrees plus or minus 360 degrees times n, where n is a member of the integers. Actually, you know what? Let's do it the other way. Let's say plus or minus 360n, where n is a member of the natural numbers. Okay, just same thing. I just wanted you to see it both ways. Okay, you know what? Let's I'll skip the last one here because I think you guys will get the idea there. All right, reference angles. So reference angles, again, this is a concept from Math 20-1. The reference angle is always going to be the angle that's back toward the x-axis. Okay? We're going to be using these a lot in a bit here, right? So, so yeah, so you can see, like, if this was our main angle, then the reference angle would be down toward the x-axis. Our reference angle in quadrant 1 is just the same as the angle. In quadrant 3, it's there, and in quadrant 4, you know, it's there. Always back to the x-axis, right? So for each of the following degrees, state what the reference angle is. All right, so for these ones, it might be helpful to kind of sketch it here. All right, so 315. So if I made like just a tiny little Cartesian plane, then 315 degrees would be, well, there, it's going to be past 270. So I'm into here, right? So it's going to be something like that. And what I'm looking for when I say the reference angle, I'm looking for this one. Now, the reference angle is quite often, sometimes it'll be written with like an angle R, or it'll quite often be given with the alpha symbol. Okay, for reference angle there. Okay, so if we're looking for that angle, well, that's just going to be, well, if you think about it here, it's 360 all the way here, right? The angle going around was 315 degrees. So what I really want, if I want what's left, then that's just going to be 360 minus 315. So that's going to be 45 degrees. All right. Yeah, let's do B for, because it's a negative one. So let's go, we'll make another tiny little Cartesian plane. And this time, so it's negative 210. All right, so negative 210. Now, since it's negative, I'm going this way, right? So past 90 degrees, past 180. I'm not at 270, so you know I'm going to be like up around here. All right, I'm getting a little crooked with my lines. That's all right. Okay, so if that's the idea, then let's see what we got going here. So I'm after this angle, right? That's the reference angle right there. So if I want that angle, and the angle from here to here was, let's say, just 210, just forget about the negative for a second, right? 210. If I go 210 and then subtract 180 degrees, right? The distance from like here to here, I should be left with my reference angle. Okay, so we'll just subtract 180. So we end up getting 30 degrees. All right. So I'm going to leave that there. I think you guys will be all right for those ones. We'll have lots of practice. So, all right, radian measures. So the radian measure of an angle is the ratio relationship of the arc length to the radius of a particular circle. Okay, so what does all that mean? Well, let's do a little review on radians. So if I draw a circle, okay, so there's my circle. And let's say we knew what the radius of this circle was. Say the radius was right there, right? Okay, so that's my radius. Now, when I say like something measures, let's say like 1 radian, what do I mean? Well, what I mean is that if I took that radius, right, that length of that radius, and then I started from here and started like this was string, like I could bend it. So that radius was just laid on top of the arc here, right? So that would also be like 1 radius long here, right? Well, that would be 1 radian. So the angle from there to there, we'd say was 1 radian. And then there would be 2 radians. And then there would be, well, 3 radians would be about there. Nope, that's wrong. Here, my scale's off. Here, let's say it was like there. And then 3 radians would be about like there. And then any idea what this would be like right at 180 degrees? How many radians that would be? Well, that would be 3.14 radians, right? That should sound familiar. That's pi radians. Okay, so that just means that you're going to get 3.4 or 3.14 radiuses if you have them extend across the arc of this thing, right? You get 3 and a little bit to get to 180. And then if you kept on going around, that would end up being 2 pi radians to go all the way around again. Okay? So that's where that comes from with our radians. We did this again like in 20-1, but it's definitely worth remembering. So now we have a formula here. Let's see if we can make sense of what this formula means. So I'm going to draw another circle. So if we drew another circle here, and again, we've got our radius. Then what this is saying is that the angle is equal to the arc length divided by the radius. So the arc length, what I mean by the arc length, is going to be the length if I started here, and then wherever this ends up, right? So let's say that it was from there to there, right? So we'd say that that was A. Okay? Now, if I want to know what this angle is right here in radians, well, really what I want to understand is how many R's go into this A, right? Like, because that's what we measure in radians, right? So if this is 1 R from there to there, right? Then if I go A divided by R, that's going to give me like 1.3 or something radians. That shouldn't be 90 degrees. I didn't mean to do that, but so that's the idea there, right? So that's just telling you how many radiuses go into the arc length. And that's it, right? That's all we mean when we say the angle, right? So that angle would be how many R's go into that A. Okay, so let's just do another quick example there. All right, so let's say we knew this radius was like 2, okay? And we were given maybe like an arc length, so arc length to like here, and maybe we were told that arc length was 2.5, right? That's how long it was, okay? Well, if I want the angle for that, then all that's going to be is how many of these radiuses go into this 2.5, right? So the angle is just going to be equal to the arc length divided by the radius. So the angle is equal to 2.5 divided by R divided by 2. Okay? So our answer here would just be the angle is equal to 1.25. Now, with radians, do we say like radians or something? Like we always give angles, don't we? You know, for degrees, we'd say 360 degrees, you know, and everything, and other units as well. All right, sorry, I got a little distracted there. I think I was talking about units. Um, okay, so yeah, the reason why we don't have any units here, right? We just get 1.25 is because if you think about it, right, this was just a ratio, right? Whatever this length was, let's say this was like 2 meters, this circle we were dealing with, and this was 2.5 for my arc length. Okay, well that would be 2.5 meters over 2 meters. See how the meters cancel? So our radians are always just going to be a number without units because it's really just a ratio. Okay, all right. So that's your little review on radians. Now, if we want to change between radians and degrees, well, we just use the other ratio. We use what we know. We know that there are pi radians in 180 degrees, right? So we're just going to multiply by like whatever your degrees is by pi over 180. And if you had degrees, it'd be 180 over pi. I'll show you some examples of like how you can make sure you got the right one, like as we're doing it, but we'll do that below here. Okay. All right, so it says convert to the other measure, right? So if it's in degrees, we'll do radians, and radians we'll do degrees. So yeah, let's do this one. So 90 degrees. You might already know what it is. That would be pi over 2, wouldn't it? But we'll see if we can get there a different way. So let's say let's write it down. We got 90 degrees, and we are going to multiply by, well, I got to multiply by something, and I want to cancel my degrees, right? So it's either going to be 180 degrees over pi, or it's going to be pi over 180 degrees. And can you see why I'm going to multiply by pi over 180? Okay, so what'll happen here, you can see that like my degrees are going to cancel, and I'll end up with no units in the end, or just an answer in radians, right? So all we have to do here now is just simplify that fraction, right? And we want to leave the pi. We want to leave the pi in this, right? I don't want to write that as 3.14 because that's an irrational number, right? I want to leave it as something pi. So yeah, we just got 90 over 180. So that'd be the same thing as 1 over 2 pi, or you'd probably write it as pi over 2 is kind of more typical. Okay, let's do, yeah, I think you guys will be all right on that one. Let's do this one in radians, and we'll change it to degrees. Okay, so I'm going to multiply it by something, and really I want to get rid of this pi, right? I want to cancel that thing. So you can see right away, whatever I'm multiplying by here, I want to put the pi in the bottom, right? Because that's what I want. I want to cancel those guys. Okay, so it'd be something over pi. So it's 180 over pi, right? Because 180 degrees and pi are the same. Those are the same angle, right? So we're able to do this. So I'm going to put my degrees on the top, right? 180 degrees and then over pi. So look, pi is canceled. So we just get, yeah, 180 over 4, or just 45, and then we're just left with units of degrees. All right, let's just do F, and then we'll call it good. All right, so we're going to multiply this by, again, I'm after this pi, right? I want to cancel that. So I'm going to write this as 180 over pi. Okay, in degrees. So then the pi's cancel, and then I'm just kind of cleaning up this mess, right? So in the end here, if you go negative 25 times 180 divided by 6, you end up getting negative 750 degrees. Okay, arc length. So arc length is what we did above, right? So in order to obtain the arc length formula, you simply manipulate, well, what we were talking about for radians above, right? This formula is on your formula sheet. And we just maybe have to solve for one or the other, right? So please, though, be careful with the angle, because it's always going to be an angle measured in radians, right? And the questions, especially diploma questions, are, you know, tricky that way. They're trying to see if you know that, right? So whenever you see something like one of these questions, they'll quite often give you the angle in radians, in degrees, hoping that you'll put that answer in, or that number in, for your angle, and then get the wrong answer for A when you solve for it, or something like that, right? So just careful on that. Now it makes sense though, doesn't it, that this would be in radians, because for all the reasons we talked about above, right? The arc length is like this is the definition of radians, right? Dividing your arc length by the number of radians that you have, or the number of radiuses. You can think of it that way too. So, all right, so let's look at this one. It says determine the arc length, or sorry, determine the length of an arc of a circle where the radius is 15 and the central angle is 5.5 radians. Okay, so this isn't too bad. So this would just be, so if we started off with the angle is equal to A over R, just rearranging that, right? We get A is equal to the angle times the radius. So A is equal to 5.5 radians. That is my angle, right? So that's just 5.5 times 15 centimeters. So your arc length is going to be 82.5 centimeters. Okay. Given that the arc length is 19 millimeters for a radius of 23 millimeters, what is the measure of the central angle to the nearest tenth of a degree? Okay, so careful on that one. So easy enough to find our angle, right? So our angle would be the arc length. So the arc length is 19 divided by 23. So our angle is going to be 0.826. And okay, yeah, even though so this would have been millimeters and this would have been millimeters, right? So there is no units. Quite often though, you'll see people just write down radians just to remind ourselves that, you know, we're talking about an angle here. But yeah, either way, you can write it as radians or not. So now that you know, maybe that might even be one of your answers on your multiple choice, right? To see if you understood. It wants it in the nearest tenth of a degree. So we have to use the trick we did above, right? And we'll convert this into from radians into degrees. So this would be 0.826, and then if I want, I can write radians just to make this look right. Times, and then 180 degrees over pi. Now, this one isn't going to cancel out nicely with a pi, right? So this one though, like this is just a number, and pi is just a number too without units, really, right? So all we can do in this case is just plug it all in, right? Just actually write this number times 180 divided by pi, and we end up with 47.3 degrees.